Hi, and welcome back to Glassboxed, writing automated cucumber tests. Today we are going to have a look at data tables for scenarios. We will look at what data tables are and how to use data tables, why we would want to use data tables as part of our cucumber test, and actually write some code where we use data tables. So first things first, what is a data table? Let's consider what a table is. So a data table contains data, and we can actually use this data table to pass a lot of information in a single step in one go. The easiest way to think about it is if we were to refer to my previous video where we pass in a single parameter as part of a step, in which we pass in something in double quotes from a step into a step definition. You could translate that into saying passing a data table from a step into a step definition is the equivalent of passing, say, an array of information from a step to a step definition. And although I said array, when we actually do this, we do this on the feature file level. So when we pass data tables from steps in a feature file into a step definition, we don't disguise it as an array, we disguise it as a table, and for good reasons as well, which I'll go into. So the user journey that I will write this test for is the following. First, we're going to navigate to the site. Then we will click on this contact link. Then we will populate this table with various data. We will send the information, and as part of an assertion, we will check that we are on the contact confirmation page. And that's it. That's all we're going to do. I have already gone through the funness of writing this test, so that we don't really waste time on something we've already covered in previous videos. So let's have a look at the test. So here, this is my feature file, and in my feature file I've outlined what the feature is. It's just to submit a valid contact form. Then I've written a scenario in which I've said again to submit a form using valid data. I have 4 different steps. In the first step, I navigate to the zoo, and then in the when, I'm gonna navigate to the contact and submit the form with valid data. And finally, as part of my then step, or the assertion, I'm just going to check that I'm on the right page. So let's quickly have a look at the step definitions. So I am creating an instance of WebDriver, and again in the given step I am creating a brand new Firefox empty driver and navigating to the web app. I am then clicking on the contact link via the ID. So let me show you that really quickly. If we go to page source, here's the contact ID for that particular contact link. I am then populating each field with hard-coded values in our step definition, and then clicking the submit message. And finally, as part of the then method, I am asserting to check that I am on the contact confirmation page. So let's go ahead and run this test and see what happens. So the browser's opened and it's clicked on contact, it's filled in the form, and it's checked it's on the contact confirmation page. So I'm going to close the browser, and if we have a look at the results, we can see that we've had a 100% pass rate, in that we only had the one scenario which passed and 4 steps all which passed. So that's fantastic. Now let me show you a flaw, well, not a flaw, just kind of something I consider to be bad practice. If we go to our step definition file, we're not passing in anything actually, we're hard coding the data we want set in the form. But hold on a minute, what if we wanted to make our cucumber file, or rather our feature file, in such a way that we were able to change this data without touching the code. Remember, one of the advantages of writing uh, feature files with step definitions is that you should have more control over what happens in your code without touching the code and only making changes on this high level. And this is a prime example where we can use data tables. Data tables can be used to pass in a lot of information in a step on a high level without going into too much detail on the code level, if you like. So what I'm going to do is I'm actually going to start writing what's called a data table as part of a step. And the way you write a data table is it's very straightforward. This is how you do it. So for any given step you want to pass in, say, a data table. Remember, a data table is almost like saying passing in an array of information. You declare the data table directly under the step. So if we look at our step definitions, it is in the "and I submit the form with valid data" step where I want to pass in this data table. So in our feature file, this is where I would need to submit the data table under. So if I go back to the feature file, it is here that I would need to write the data table. Now, what do data tables look like? Well, they quite literally look like a table of data. So you could have, if you like, column names here. So I'm just going to say this column is called fields, if you like, and I want another column with something like value, if you like. So these are the headings of my table. So I have 4 fields. I've got a name field, I have an address field, I have a postcode field, and I have an email field. Now, when we ran our test, this was the value that was getting passed in. I don't want to do that anymore. I want to have the ability to pass in whatever value I want and change it at will only on the feature file level and not on the code level. So I'm going to make up some names. The name I'm going to pass in is Jack, Joe. The address I'm going to pass in is Happy Land. The postcode I'm going to pass in is A1S22, and the email address I'm going to pass in is I will subscribe to this channel. So this is the information I want to this is vital. Sorry. So this is the information I actually want to pass in, and this is what I want the form to be populated with, as opposed to these hard-coded values here. I'm just gonna use the pretty format to format this, and I think you can see why this is called pretty format. It prettifies everything. Prettifies is a technical term that I made up. Use it if you like. Okay, anyway, moving forward. So we now have this step which passes in this data table. And this means we now need to make changes on our step definition as well, because we need to cater for this. This won't just magically happen. We do need to plug in the logic code for this data table to be acceptable by this step definition. Sorry, this step in this feature. So let's go ahead in the code file and make it happen. We've learned from previous videos that when we pass in parameters, we need to indicate it here as part of a register pattern in the step, as well as declaring a variable type and a variable name to use when we pass in that parameter, and it gets picked up as part of the string. Luckily, data tables don't behave in that exact manner. They're slightly different, and they're different in this way. All we have to do is just pass in a parameter, and the step automatically knows that it is passing in a set of information. And we can do this in many different ways, but Cucumber's take on this is to declare what's called a data table. and I'm going to give it the name table. So data tables, you do need to import this in, and notice this is part of the Cucumbers API. So data table is this. So when this information gets passed as part of this step to the step definition for that given step, the information passed in the data table is converted to, well, yes, a data table. And it is this table that we use to get all the necessary information. Now, I'm not entirely sure how much more detail I'd need to go into about arrays, but a data table is effectively, it can be treated as a 2D array in that there's two sets of information. I hope you understand the concepts of a 2D array. If you don't, we can go through it in more detail going forward. But for the moment, I'm just going to assume you understand what a 2D array is. I'm going to show you how to use it anyway, so it shouldn't be too big of a problem. So the way we use this data table is, first of all, this data table that we're getting is given to us in this data format. So just to show you, I'm going to do a system out print of the table in what it looks like. I'm going to save it, and I'm going to run the feature file just as concept that all our setup has worked so far. So I'm going to run it, and let's see what happens. So it's opened the browser, again clicked on contact, filled in the form, and checked we're on the right page, and close. Okay. So we're interested in this because this is what we printed out. And noticed, well, it's already gone now, but when the contact form populated, it didn't use any of this information. It didn't use any of this information. It used the information that's hard coded in our send keys methods, because we haven't passed in that information yet. But anyway, more importantly, this is the data that it passed, printed out in the step definition. So if I just go to the step definition, okay. So this is what printed out this data here. So we now definitely know that this information is definitely getting passed to the step definition. Now we just need to be able to pull this information and use it however we will. So the way I like to do it is, because there isn't a vast amount of information here, and all the columns are in that order on the web page. So if I go back to the page and go to contact, the name field is always first, followed by address, postcode, email. This will probably, the ordering of this column will probably never change. So I can quite happily assume they will always be in that order. So I can, when I write my logic code, I can cater for that. And the way I do it is this. What I do is I create a new list, and lists effectively contain, if you like, objects in whatever order you pass them in, and they always contain objects of whatever type you declare it to be. So if I said something like a list of strings, this list is literally like a shopping list, if you like. So I don't know, milk, tea, eggs, and so on. It's a list. It's a list of things. So in this case, this is a list of string. Yeah. If I say something like a list of int, for example, which is numbers, then I can say something like 2, 4, 243, anything. So a list contains a list of things. Now, because our data table we're passing in is a 2D array, what our list will contain is another list of something. The data table that passes in data by default, all of these values, including the column headings, are strings. So what we're going to pass in is string, and I'm going to call this 2D array data, and this is going to be equal to table.raw. Raw is what returns, if you look here, a list of strings. And I'm just going to import that in. Importing as a java.util, lists are part of the util class. Okay, and I'm just going to comment out this because I don't really need it. But what I'm going to do, again as a proof of concept, is I will try and print out just this value here from this data list we have here. So I'm going to go system.out.println. It's going to be data.get 1, Now, why do I say 1? Well, when we pass in this array, what happens is, first of all of these rows are being passed in as a list, if you like. So this is row 0, row 1, 2, 3, sorry, 0, 1, 2, 3, 4, yeah. And again, probably another important information, lists and various other arrays, they all start from 0 position, yeah, not 1. I can spend a long time just explaining what lists are and all the rules that are governed, but that's a whole different subject, and that will take time. So I apologize if lists look a bit confusing, but like I said, I'll give you all the tools you need to make data tables work. But if you want to get a deeper understanding of the various different types of lists, then we can go through that possibly in another video. But again, ignoring that, that's for a different video. Right, going back to what we were discussing, so we're going to get the data with an index of 1, which quite happily puts us in this column. Sorry, in this row. So now in this row we have two values. We have a name, which is most likely at position 0, well, which is at position 0, and we have Jack Joe, which is at position or index 1. So now we're going to do again another get at 1. Close that off. And now let's run our feature file again, expecting Jack Joe to be printed out. Okay, close the browser, let's have a look. And we have Jack Joe that printed out. So this was definitely picked up as part of our data. So now we know we can grab this information. So now we're just going to put this information in our table here. So the name value, we're going to give it this, and we're going to do the same thing with the other values as well. So this is going to be the next row down, and so on. And these ones will never change because they are always on the from a 0 based index. These are all in the first column. So now, just to make sure that we're definitely doing this, what I'm going to do is I'm actually going to remove this step. In fact, yes, let's remove this step because I don't want to, because I just want to show that this information is being populated. And I'm going to go in and I'm just going to comment this out so we don't submit the form either, just to prove that we definitely have the right data. Save it, and now let's run and see what happens. So just open the browser, go into contact. Okay. I minimized the browser there for a moment. I probably clicked on my my Eclipse. But if you have a look, it's done exactly what we expected. So it's as opposed to name value is printed Jack Joe, as opposed to address is Happyland, postcode is postcode, and the email is I will subscribe at to this channel. So it's placed the values we want in each given input fields exactly as we wanted. So I'm just going to bring back the final step, just so we have confidence that our test does fully run. And now I'm going to run it again, the whole thing, just for completeness sake. And there you go. Just kind of making sure again this works. I'm just going to change this to something else. So Billy Bob, happy, I don't know, super happy land. Let's pretty format this again, and let's run this, and just keep an eye on these two values. And it's put in the values we wanted. Perfect. So the purpose of this video was to demonstrate the power that data table brings to the table, and you can see this is actually very powerful. So in my previous video I talked about parameters where we pass in, say, a single value like this, for instance, where the color changes and we've identified this as a parameter, and so on. In this video, we've discussed almost a very similar concept, but on a much more grander level, in that we're passing in a lot more data with the ability to change this data at will, most importantly without touching the code. So the last test we just ran, we changed the name and the address without having to care about what the code is doing, and this achieves exactly what we want. And if we have a look at the results, again we've got 100% pass rate. So this is effectively what data tables are. They allow us to pass in a great deal of information through a single step, showcasing the power they have versus the amount of effort you need to do if you were to write, say, multiple different scenarios. Again, you can represent this using multiple different scenarios, but it's always better to do this because it also makes it easier to maintain over time. And that's it for this video, folks. I hope you've enjoyed my videos and find they bring some new knowledge or insight into writing cucumber tests. And if they do, please subscribe, rate and comment. If you have any questions or video suggestions, then please leave a comment below. Many thanks for watching. Until next time, ciao.